Hey, what's up YouTube? Welcome to another Moralis video. Hardhat is one of the most powerful, reliable, and efficient frameworks for smart contract development based on JavaScript. It has really powerful tools and a huge collections of plugins, which is going to make your life as a smart contract developer easier. So today we are going to learn how to deploy your smart contracts using Hardhat, really easy, and then we are going to see how we can use that on a real project using Moralis endpoints. So if you want to learn how to do this, keep watching. What's up YouTube, my name is Vasily, your Web3 instructor from Latin America, Ecuador. I've been building on the space since 2020 with cool crypto projects. In my free time I really enjoy singing and playing the guitar, and if the time is good, I like to go out and take some meditations. But enough about me, let's go back to the video and start building. For reference, don't forget to give a look to the official Hardhat tutorial, because if you get stuck on some part of the tutorial, you can find important information over here. This is going to be a really easy process, so let's get started. Here I am on my console on a new project called Video Hardhat Deploy. So the first thing we need is to start a new node project. Don't forget to have npm installed on your machine to do this. So first we need to say npm init. Yes, this is going to create a new package.json on which we are going to install all the dependencies we need to start using Hardhat. Then we need to install the Hardhat dependency with npm install Hardhat. Don't forget to use this for install it just for development purposes. Let's click enter. Once we have this package installed, we can create a new project using npx Hardhat. We have two different templates, one for JavaScript and one for TypeScript, but for now let's create an empty Hardhat config file. This is going to create a new JavaScript file on which we are going to put all the Hardhat configuration needs. So let's open our code editor over here. At first, the only thing we have here is the Solidity version the compiler is going to use, and here we are going to put all the information we need. Usually we need to install some default plugins for Hardhat, which are Hardhat Ethers, the library Ethers itself, and Hardhat Waffle, including Ethereum Waffle and Chai. We are not going to use all of those on this tutorial, but it's a good practice to have them all for your Hardhat projects. Don't forget to check out the Hardhat documentation to get these commands, or check the GitHub repo related to this video, because you are going to find all you need there. Once this process finishes, we can continue. So on today's tutorial, we are going to deploy your smart contracts on the Sefolia testnet. So for that, let's first declare new default network, which is going to be Sefolia, and then we are going to declare all the networks we might use. So networks, inside of here we are going to declare the default network, which is Hardhat. This is for local testing, and then we can add the Sefolia network. Here we have to provide three things. One, the URL of a RPC client such as Alchemy or Infura, the accounts we want to use, and of course the chain ID. And for Sefolia is this number. So first we need the URL. Today we are using the Infura endpoint, and here we have to provide our Infura API key. So I'm going to transform this into a variable called Infura API. And for the accounts is going to be the same. We have to pass an array of accounts, and here we have to provide the private key we are going to use for the deployment. Of course, we don't have these variables, and a common practice is to create a new variable for each one of those, and this is it. But this is not a good practice, because this is going to make your API keys vulnerable. So for that is a better practice to create a .m file and store all that information over here. And if we want to push this code to a code repo like GitHub, we can add this to a git ignore and keep our keys safe. So I'm going to delete this, and instead of that, I'm going to create two variables, which is going to take that from the EMB. Of course, to load the information from the EMB, we need to install the library for JavaScript.m. With that, we can require .m from the config, and here we can store our key. I just pasted mine over here. Remember not to share this information with anyone, because this is sensitive information, and your private key is going to come usually from your MetaMask, and the Infura API key is going to be on your Infura dashboard. So with that, we already have all the configuration we need for Hardhat, and as easy as that, we are ready to start deploying our smart contracts. So as example, let's first create a new folder called contracts and create here a really simple smart contract. This smart contract is called my contract, just have a constructor on which we are going to pass a message, and we have two functions to update that message and get the value. This is really easy. Once we have our smart contract ready, we can create another folder called scripts and start the deployment process. It's a good practice for Hardhat projects to enumerate or deployment scripts. So I'm going to say 01 deploy contract.js. Let's declare an async function main, and here we need to add the logic for the deployment. However, to do that, we are going to use the Hardhat plugins we just installed. So we just need port from Nomic Labs, the Hardhat headers library. First, you need to create a factory for your contract. This is going to be the one responsible to deploy the instances of your contract, and here you have to pass the contract name, in this case my contract. Once we have that, we can just deploy the contract. So we use myContract.deploy, and as this smart contract requires a constructor parameter as a string, we are just sending hello world. Notice that this myContract and this myContract has a difference on the initial letter. One is the factory contract, which is going to deploy, and this is the instance. Just to have information of the deployment, let's create a console.log and print the contract address. And as easy as that, with just 5 lines of code, we have all we need to deploy this contract. So let's save this script. So we have here our main function, so we just need to execute it. I'm just going to call in main and add in some error handling over here. With that, we are ready to deploy this. First of all, we need to compile the smart contract. So we can use npm hardhat compile, and this is going to take the Solidity smart contract and compile it to make it compatible with the Ethereum EVM. Once the contract is compiled, we can try to run this deployment code. Of course, when you are developing your smart contracts, you will not want to always deploy to a live network, but instead you will want to deploy locally in order to test everything works fine. Fortunately, Hardhat comes with its own internal blockchain, and if we run npx hardhat node, we can now see we are going to have all of this. This is an internal blockchain Hardhat is running for us, which has a lot of accounts with their public keys and private keys and a lot of ether to test this out. We can keep this running and then try to run the deployment script, but on the latest versions of Hardhat, we can just run npx hardhat run scripts, the name of our script, and specify the network. As we set it up, the default network in Sepolia, we need to specify we want to deploy this locally. If I hit enter, as easy as that, we have our smart contract deployed. Let's try and use that smart contract functions we just created. So over here, I'm going to say the current value is going to be equal to that get message function I have on the smart contract. Let's console log this, and now let's execute that another functionality which is going to update the message. Again, we just call the contract instance and call that function update message. And as always, we add a .wait block in order to wait some block confirmations. Finally, we are just going to take this code, paste it over here, and change this to new value. So our objective is to deploy the contract with an initial sentence stating hello world, and then update that to this string, a new message. So let's save this and run this again. And yes, as easy as that, we have it. We have the smart contract address of the deployment, the initial value, and the latest value. And with that, with just a small portion of code and a little configuration, you already know how to deploy your smart contract using Hardhat. Of course, this was a really simple example, so let's take a look on how we can use this on a real project. So here I added a new smart contract, which is a standard RC721 contract for NFTs and has all the functionalities you should expect from an NFT contract. I'm using the OpenZeppelin standards. So first of all, in order to be able to compile this, let's install OpenZeppelin. So let's go back to the terminal and say npm install add OpenZeppelin contracts. Once this is done, we can create another script to deploy our smart contract. This deployment script is going to look almost the same as we just used, but instead of using the my contract, we are going to use the Sepolia NFT contract I just showed you. This smart contract does not receive any parameter on the constructor, and we can just deploy this as it is. However, I have here more imports, and the reason is because here I have a new folder called Frontend on which I have the frontend for my project I'm going to show you later on this video. So basically, I'm going to use the standard JavaScript libraries to automatically send the deployment address to the Frontend folder, so we can use that when we are interacting with the smart contract. This step is 100% optional, but it's just to make our life easier. So let's run the deployment code, but instead of using the local network for Hardhat, let's use Sefolia. Remember, that's why we added all that configuration here on the Hardhat config to be able to deploy to a live network. So let's hit on enter. This is going to compile automatically the code. Actually, the npx Hardhat compile is not needed. I just wanted to show you for you to know how to compile the contracts. And now we have the deployed address. This is actually on the Sefolia network. We can just copy this, go to Sefolia etherscan, paste the address over here, and as you can see here, the contract is already on this live network. And also thanks to the functionality I added, here on the frontend folder, on the src folder, we are going to have this contract config on which we are going to have the contract address we just deployed. Remember, to interact with a smart contract, you are going to always need the contract address, the contract API, and the account which is going to sign the transaction. So for that purpose, I'm going to add another extra script on this project, which is going to use the same logic I just showed you to send over the contract address, to send the contract API and the chain info to the frontend folder. The only thing we have to change this, if our contract is named differently, is the contract name. So I can just run again this. Let's clear the console, npx hardhat run scripts send to frontend for the Sefolia network. And now our frontend folder on the src, we are going to have this config.json, which is going to have the chain ID and all the contract API. Again, these steps are optional. You can always take this manually from the artifacts folder here on build info, here on the contracts, but this script is just to make our lives easier. Once we have this, we can use this on the frontend project. So here I have a template project I used for another video, which has the capabilities to mint different NFTs based on your selection. So you can get a different Viking depending of which class you choose. So first thing first, we need the functionality to connect the wallet, which is pretty standard. In order to accomplish this, you just need a handle connect function, and using ether.js, well, you are going to be able to get the signer, the account, and verify if the wallet is already connected. Then we have another function over here called handle meet, which is going to interact with the contract. Again, to interact with a contract, we need the contract address, the API, and the signer. The signer is going to come from the MetaMask wallet, and to get the contract and the API, well, that's why we imported this config.json and contract config, on which we are going to have that address we need and the contract API. So we just need to add the corresponding imports. The contract API is going to come from the config, and the Sefolia NFT, which is going to be the contract address, is going to come from the contract config. Then we can declare two different variables to get that specific items, the contract address and the contract API. With that, we can just go back to the project, select the Viking we want, let's say we want a mage, and click on mint. This is going to trigger a new MetaMask transaction. We can click on confirm, and as easy as that, we just minted a new NFT. We just need to wait until this transaction finishes. So, how we are going to get the NFTs from the blockchain? There are several ways. The best and easiest one is just to use Moralis. Today we are going to use the endpoint get NFT owners by contract provided by Moralis, which provide us the code to get the information out of the blockchain on different programming languages such as Python, Go, PHP, but as we are using JavaScript today, let's keep using the JavaScript endpoint. And by the way, if you don't have a Moralis account yet, this is the part of the video for you to hit pause, go to moralis.io and create your free account. Here on your admin panel, you are going to have the access to your free API key. This API key is really good for basic projects and basic petitions, but if you're working with a big NFT collection or marketplace, step up your blockchain game with Moralis Pro. With twice the computing power and more requests, you can handle even the most demanding projects. Plus, enjoy unlimited daily records on your streams with automatic retries for a seamless experience. And with more replays and longer retention for your historic streams, you'll never miss a beat. Don't settle for basic, upgrade to Moralis Pro today and take your projects to the next level. So to be able to make the request to this endpoint, we are going to need a little server on our project. So here on my main folder, I'm going to just create a new file called server.js. And here we are going to create a really simple server to call that endpoint. We are going to need some dependencies. First, the .env on which we are going to start our Moralis API key, Express and Moralis libraries, and here we are going to declare the first steps of our server. The app is going to be equal to Express. We are going to use cors to bypass some security measures, and we need to specify the port on which our server is going to run. As default, React projects run on the port 3000, so we are using 3001. But of course, don't forget to add those requirements to your project with npm install Moralis, cors, and express. We are going to say app.useCors and app.useExpress.json. Now we need to declare the Moralis instance, so I'm going to say moralis.start, and we need to pass the API key, and we are going to console log that we are listening to new API calls on the port we are running the server. Of course, remember, you should not add your API key over here. This is why this should be stored on your .env file. So let me copy this Moralis API key, go back to the .env file, put an equal over here, go back to my Moralis admin panel, copy my API key and paste it over here. And as easy as that, we have a really simple server. Of course, this server is not going to do anything for now because we need to add the functionality to interact with this endpoint. So let's create a new one called app.get. The endpoint is going to be called getOwners, and inside of this we can use that Moralis functionality. So first we are going to get the contract address from the frontend. Then we are going to use a try-catch statement just for error handling. And inside of the try statement, we can just go back to the Moralis reference page and copy this information. So we are going to take this response, copy this, go back to the code and paste it over here. The only thing we need to change is, first of all, the chain, because we want to use Sepolia. This is the code for Sepolia. If you don't know where I'm getting this value, you can again go back to the page and look over here which are the codes for each network. We are not going to use this media items parameter, and instead we want to have our metadata normalized. And finally, I'm going to replace this example address, which is actually for the CryptoPunks, and use our contract address we are getting from the front. If everything goes well, I'm going to console log that response and send that response to the frontend with rest.json response.raw. And as easy as that, we have a functional server. Now we can run this server on the terminal with node server.js, and this is going to be listening to new API calls. So on the frontend side, I have another function over here called refresh NFTs, which is going to connect to that endpoint and render all the NFT information into a card. And you may notice that I'm not using here the actual server address. And the reason is because here on the package.json, I added a proxy pointing to the localhost on the port 3001, which is exactly one I'm using for my server. So if everything goes fine, I can go back to my frontend, connect my wallet, and if I click on get my NFTs, this is going to render the information of the NFTs I have on this specific smart contract. Remember, we choose the mage one, so here we have all the information for that NFT. Also remember, this is just to showcase how you can integrate this into a real project, but we already have a specific tutorials step by step on how to do this on a deeper level. But as you can see, as easy as that, we deployed our smart contract with Hardhat and then use Moralis endpoints to get the information out of the blockchain and then render all that into our frontend. And that was it for today's tutorial. Don't forget, all the code for this lesson is on the GitHub repo, so check out the link on the description. And as you are already here, click over here to subscribe to Moralis channel, turn on the notifications, and also check out more videos. Thanks for watching till the end, and see you on the next occasion.